Hello, everybody. Thanks for coming out to Build. My name is Edward Thompson. I'm a program manager for Microsoft's Visual Studio Team Services. And with me, I have Jill Campbell. Jill is a group program manager for the Windows engineering systems. That's the team that is in charge of helping the developers on the Windows team get the ideas out of their head and onto your devices. We're going to talk a little bit about how they do that and how her team helps them and how they use Visual Studio Team Services to help enable them. If you're not familiar with Visual Studio Team Services, it is Microsoft's application development platform. It starts with collecting the work items and planning the work that you want to do on your project. It enables that with some visualizations like Kanban boards and burn down charts. Once you've got your software project planned, it enables you to collaborate on the code. Visual Studio Team Services will host your Git repositories in the cloud, in Azure, and allow you to collaborate on them with pull requests and keep them safe and secure with things like branch policies. And once you've got your code checked in, Visual Studio Team Services can build that code, again, with virtual machines hosted in Azure, and then deploy it. And that's true whether you're deploying a web app into the cloud, or a mobile app to the device in your pocket, or an operating system on millions of computers. Now, we use Visual Studio Team Services a lot within Microsoft, but it wasn't always like that. Once upon a time, when I started at the company about 10 years ago, the polite euphemism for this would be we lived in silos. The Windows team was very separate from the Office team, was very separate from DevDiv. We didn't collaborate a lot, and we certainly didn't have any sort of common standards as far as tooling went. The Windows team used, for source control, a product called Source Depot. You've probably never heard of it because it's something that we built within Microsoft. And over on my side of the company in DevDiv, we were working on a product called Team Foundation Server, which became Visual Studio Team Services. And it used a similar but different version control system called Team Foundation Version Control. It's kind of the successor to Source Depot in a lot of ways. This is not efficient. And so we set out on a plan to break down these silos. It's called 1ES. In Microsoft fashion, we've got an acronym for everything. 1ES stands for One Engineering System. The idea would be that we would have one engineering system for one Microsoft. That we would enable a culture change throughout the company to allow us to collaborate between products. So now, if I want to make a change to Windows, I can clone their repository, make that change, and send up a pull request where hopefully it gets closed immediately because I promise you I should not be writing kernel code. But the goal is there that we can enable this sort of collaboration throughout the company, and this is a mandate from the highest levels. We believe that this culture change is important to Microsoft, that it is crucial for us to be able to build and deliver software to you effectively. And 1ES is about the tools that enable this culture change, and that is where Visual Studio Team Services comes in. Visual Studio Team Services, the VSTS team, of course, we use VSTS to build VSTS in an Inception-like moment. Of course, we eat our own dog food. But the fun thing for me about being part of this 1ES mission is to see all the teams within Microsoft that are adopting Visual Studio Team Services and the different ways they're doing it. You've got teams like Visual Studio Code, who really is building an open source project. So they're not using VSTS for the code management. That all happens on GitHub. That's where you collaborate on open source projects, and so that's where their code lives. But they use VSTS for our build agents. Again, we have hosted build agents in the cloud, so they're able to do their cross-platform builds, Mac, Windows, and Linux, in VSTS-hosted virtual machines. And then you've got teams like the Microsoft Teams team, which is a bit of a tongue twister. And that team is a nice greenfield application, right? They kind of took all of the Visual Studio Team Services offerings and just went to town. And they use that to build and deploy a web app and an Electron desktop app and mobile apps. And all of these teams bring unique challenges to the VSTS team when we have to support them. And it's really been fascinating to see all these, and it's been fun to work with these teams. But there's really one team that brings truly unique challenges. It's a team that's bigger than any other team that we work with, and that's the Windows team. And now I'd like to turn it over to Jill to talk about some of the challenges that they've had adopting Visual Studio Team Services and how we've worked together to enable them.
All right, thank you. Hi, everybody. So I'm here to talk about Windows. Windows is a lot of things. Windows spans everything from HoloLens to Hub in terms of device categories we support. And to create something that spans across all of those device categories, we have a lot of code. Our code is built in a couple different ways. We have one core, the common OS that we bring together that all of those devices run on. We have edition-specific code that sits on top of those that make the individualized experiences for each of those devices and form factors. We then have drivers we create and ingest. We have apps that sit on top of all of those layers. And we have services that run alongside. And all of this, as you can imagine, across all those form factors creates a lot of code and a lot of repos. So we have 500 gigs of source code, and we have about 6,000 repos. So we have a lot of form factors we run on. We have a lot of code we've got to manage. And we have a lot of people that steward and manage that code and those devices. So Windows and devices, one way we like to think about it to kind of keep ourselves in the right mindset is the group of people that it takes to create Windows and devices is bigger than many companies, sometimes much bigger than big companies. And that helps keep us grounded in the challenges we face when we seek to scale solutions like VSTS. That creates enormous scale on every dimension. I love this slide because it's big. A lot of my theme is going to be bigness. And you see from this, we have 11,000 engineers that work checking in, that work on our account. We have 7,000 that actually check in code to that 500 gigs of source code I mentioned. That creates about 500,000 pull requests per release. That creates 3 billion test cases executed per release. It's one of these things where the numbers for our scale get so big, they feel kind of fake or funny numbers. It's like, it gets you in the mindset of, wow, the challenges that we face across that large a scale is significant. That becomes then compounded by the fact that we have all of those devices working on all of that code with all of those folks across that scale shipping at every frequency imaginable. We used to live in a world where we had one big release every 2 to 3 years and we could focus on that. Now we have teams in those layers who are shipping a couple times every day. And we still have things like devices that need to be shipping in 18-month to 24-month cycles. So you can see the matrix of challenges that presents to us when we look to move to a solution like OneES. We were thrilled to do this. As Ed mentioned, the inefficiency strikes all of us as having a siloed, independent, unique solution for every problem that the whole industry is facing is not an efficient way to work. So we started our journey about 5 years ago towards getting to an aligned OneES solution. So I thought I'd show you where we are in the journey and across the different pillars that Ed talked through. So let's start with planning. How do you get 11,000 software engineers to work independently and also work together. Actual picture of actual WDG engineers doing an actual 12th-man flag. So how do you get them to work together? So we have sort of two things we try to keep in balance across those 11,000 folks. One, we do have things where we need to be able to see far. We used to call that waterfall. I think folks think that's a bad term. But we have things where we need to make predictions, and we need to be able to say, in a year at Build, we want to talk about X. In a year at Christmas, we want to launch Y. So we need things that have the ability to see far. But we need for the teams and for the organization to be able to respond to changes, to be able to adjust plans. We need to be able to operate nimbly. So the way we try and structure this is with a taxonomy. So you've probably seen this in other things. It is a foundational way we keep our work organized. The top layers, the top of the taxonomy, keeps our work aligned. It's the stories we want to tell our customers. It's the promises we want to make to our customers. It's the work that at the executive level, we care about the teams working together towards production. At the bottom level, you have the work the team is doing, the daily grind of getting code, task, deliverables in and out of the system. And that taxonomy helps us keep focused on which work is laddering up to the big thing we're trying to do in N period of time, through to what's the stuff the team just needs to churn on. Because it is the case that when you have 11,000 engineers working in one work management system, it creates a ton of work items. It creates a ton of stuff. We have 11 million work items in our account. We have 350 million revisions in our account. We run 2.5 million queries and updates a day. So having that level of data in the system is overwhelming. And so we use the taxonomy to keep it aligned, to keep it focused, and to help us understand what's the work we need to focus on for the thing we're trying to produce, and what's the work the team can just work on independently. I show these numbers to give you a sense of scale. So you can see we have about 43 external stories we want to be able to tell at the end of any particular release, which creates hundreds of thousands of work items that sit underneath it, laddering up to it. With that in mind, it is still, hundreds of thousands of work items is a lot to navigate. So we were excited when we onboarded to 1ES, not only that it had built-in agile templates we could use and built-in structure and process we could use, but that it had extensions. And so we could build customized views to help us with our 3 biggest problems in the work management space. The first, I showed you a sea of data. If you're a fancy person, you want to see how all of that work accrues to the high-level story you care about. So we needed a way to show the big picture. Is the work coming together? Do I need to be worried? We also needed a way to talk about the things teams owe each other. I always think of this as in that sea of data, there are about 10 items per team that'll get you in real trouble if you don't deliver them on time. The things where someone and a cascade of work is dependent on you doing something. And those are dependencies. And we have team execution. The team needs to be able to see what they're working through and what's on their radar on a regular and consistent basis. So with that, we built a set of extensions to allow us to do that. So I thought I would show them. The first one I wanted to show, and again, this is in the work management space, showing folks against those 3 problems we're trying to solve, is Story Tracker. So along the left, which I've hidden for probably obvious reasons, is the whole list of stories we're working on for the next release. I picked one that's our story, the engineering systems story, so nice and safe to show, that shows you the high-level view of what is the work. How is it coming together? So at this very top level, you can see what teams are working on it with you, what the state of all the work items is, and as you scroll through, you start to see how they all align to the promises we want to tell, where we have dependencies, because I mentioned those are the most critical work items, and if you expand them out, this is the one I particularly work on, you can see how things are coming together, what the state are, how many you have, and in what state they are. So that's at the big picture level. And so our executives use this every 6 months as we're prepping to see how are things coming together, how do things look, does it look like there's areas of risk. Then we have dependencies. Couple key things you care about with dependencies. Remember, dependencies are the work that I require from you to do the thing I need to do, or that you require from me to do the work you need to do. So the first thing we said is, what's the thing you care most about in that realm? Well, you care about where you have risk. You want to see a map, a heat map, of where is the biggest area of risk. So this shows you that. This is filtered by team. As you can see along the top, there's a variety of filters I can choose that shows what are all the teams that owe me work so that I can achieve my story, or I can achieve the work I've set out to achieve. And you can see this all along the left. There's about 200 of these. So when I show that taxonomy with 130,000 tasks with 38,000 deliverables, this helps curate the 200 that really are critical path for getting the rest done. Allows me to operate nimbly while being able to see far. Within this, we then probably want to see the state. So once you have a view of the risk, you're like, great, but now I want to drill in. I saw an area of risk. I want to go deeper. I want to understand it. So we built a customized view to show you state and per team. And this works across the accounts at Microsoft so that you can see where you have work you need from other divisions. Finally, we built a view that's got all of that mapped out by time. Time is a pretty critical element, and so what you want to see is how the work flows from one month to the next and which work is required for the next work to begin. So this shows you at the aggregate level, and it shows you each piece of work and what it's going towards in the future. Finally, if you're a team, you care about your daily grind. You care about, we work in increments of a month. We split those lower if you're a team that ships more frequently, but we align at the month level. So you care month to month. How is the work coming together? So again, a view that shows you what is the work I'm on the hook to do this month? How's it coming together? How's it looking? Where do I have things moving out? They're delayed. Moving in, they're coming in ahead of schedule, or things that have been moved out several times, so they're really behind. This is how we use the trackers. We're going to flip back. And that helps us stay aligned and autonomous at the work level, and it's all created and on a foundation of Visual Studio Team services through their customizations.
Cool. Thanks, Jill. So the next step, once you've planned your development process, is to actually write the code. And just like work item tracking has some challenges scaling to that many users, version control does too. So on average, we can look at the Windows team producing about 367,000 commits and managing that over 33,000 pull requests. That works out to about 10 commits a minute and 1,100 pull requests a day. This scale is immense. So you can understand why they had built Source Depot to be able to manage that back previous to 1ES. But moving into 1ES meant adopting, ideally, a new version control system. That's not an obvious answer to this question. We did actually analyze whether Git would really make sense for the Windows team. We looked at Git versus Source Depot, and fundamentally we found that Git was really the only solution that could meet all our needs, with one exception, and that's the top one. The number one requirement is large scale, and you'll notice it's a big red X in the beginning. Now, you might be wondering about this because actually on the Git webpage, I visited this morning, gitscm.com says that Git was built to work on the Linux kernel, meaning that it's had to handle large repositories from day one. Okay, so why did we have a problem moving Windows into Git then? Linux is a big repository. If you compare it to some other open source repositories, if you want to compare it to Roslyn, Roslyn's about 230 megabytes of source code when you check it out, of documentation, of tests. The Git repository that manages the Git version control system itself is a mere 34 megabytes. So Linux does look really big. It's about 650 megabytes checked out. That's about the same size, if we look at repositories within Microsoft, as the Azure Compute repository. That's the code that runs when you click New Virtual Machine in the Azure portal. My team, the Visual Studio Team Services team, our code, our source tree is about 3 gigabytes checked out. It's quite a bit bigger than Linux, I guess, but it's about the same scale. But this isn't a big repository by Microsoft standards. Within Microsoft, there's one really big repository, and that's the primary Windows repository, which is about 350 gigabytes. So it turns out that although Git was made to handle large repositories from day one, it wasn't made to handle this repository from day one. And so when we sat down, the VSTS team and the Windows team, and tried to put this main repository into Git, it was a little slow. It took us about 12 hours to clone it. And then once we had that cloned, we ran git status, and we waited about 8 minutes, and it finally told us that nothing had changed. So we were not real happy about that. The goal of 1ES was to improve developer productivity, and this is anything but. So we created, between the Windows team and the Visual Studio Team Services team, we collaborated to build a tool called the Git Virtual File System. You can think of GVFS as sort of like OneDrive on demand, but for your code. So when you run git clone, you don't actually pull down all of the files in the repository. You don't pull down all of the history. You just pull down the metadata about your tree so that we can show what's there. And then as you actually access the files, we'll interrupt that. We'll download the file from Visual Studio Team Services, and then we'll put it on disk. The idea is that if you're working on, say, Notepad, you don't care about a SCSI driver that ships in Windows Server. You don't care about the Xbox code. You don't care about the code for Store. And so you don't actually need the entire source tree, all 350 gigabytes of that, in order to do your work. GVFS will just page in what you need on demand as you need it. And that efficiency, A, means that your hard drive isn't full of 350 gigabytes of source that you're not necessarily using, and Git can be optimized to only look at the files that you actually have locally. And this is completely transparent. Your application thinks it's talking to NTFS. GVFS actually sits in between and intercepts that call transparently. So you can keep using the same editor, you can keep using the same build tools. They don't need to be made GVFS aware. And this was the difference between 8 minutes to run git status and 8 seconds. So it's an incredible change, and it's what allowed the Windows team to move into a Git repository. And if you're thinking 8 seconds is still slow, we agree, we're working on it, but one thing at a time. The most impressive thing to me, watching Windows adopt Git, moving all of those developers into a completely new version control system, was that they were able to just pick up and move over. Obviously, we moved some teams in as a trial run to test everything out, to get everything ready. But you can see the big switchover moving from blue to orange when the majority of teams adopted Git. Everybody was expecting a massive drop in productivity that day, but unbelievably, they just started opening pull requests with Git. It was completely unbelievable. So sometimes we can't just build extensions into Visual Studio Team Services in order to work. Sometimes we actually need to pair up and work very carefully together. So with that, I'll turn it back over to Jill.
Awesome. So let's finish our journey through how to work together in 1ES with build, deploy, and monitor. So we've planned our work, put our work in Git. hosted the source. So now we need to get that code out to you, out to master. And in a perfect world, you are working as close to the head as possible. Not new news, but very hard to do when you have 7,000 people working concurrently trying to hit master. So we think of this as a traffic analogy. If you're just a couple cars on two small roads merging, taking your code and merging it up to the master road, pretty straightforward. You can see collisions as they're about to happen. You can predict problems before they happen. Much harder to do when you have 7,000 engineers all trying to get to that one endpoint. And so in the same way that this causes a lack of productivity, we don't want that, we had to find a way to get our code to flow so that you at the inner loop level, our developers could still be working quick iterations, have a short inner loop, but get that code up, get that traffic jam to not happen at a level that slows them down. So what we've done with that to solve that for now, and then I'll talk about where we're going next, is branching. So branching you can think of as those side roads that you pre-merge before you get to the big highway. So we have our top level branch where very little happens. That's mostly at the most integration level. And then L1s, which are the big teams where they bring all their code together. But if you're a developer in Windows and devices, you're mostly working at these lower levels, quickly checking in, quickly monitoring your health, quickly merging your changes. So we've built a set of tools to optimize for flowing that code up. I was hoping to show this live, but I've taken screenshots since we're in early release phases for the next release. What you see here is a dashboard that's fed information from a variety of sources, including VSTS, that presents you, as the owner of a branch, a view of health. Is it safe to merge my car onto the highway? We start with a few things you're going to care about. What are the branches and what's their overall health? Is it stable? Where are you in space and time? So we have a calendar view that shows you what forward integrations you're getting, what reverse integrations you're getting. And then you can schedule yourself, your large branches, on this calendar so that you know when your code's going to move up to master. And as a branch owner, you get to toggle this and play with this and reschedule this. So one place you can go to see status and to see where you are on the calendar. You can also use this to drill in, again, taking those feeds of data from VSTS to monitor the health of your branch. And so what folks care a lot about is what are the build results? What are the test results? Did I do my failure triage? And self-host. Did enough people use this build that I feel confident that there's no hidden issues? Did enough folks do the scenarios I said were critical so that I can feel confident moving this code up? And because again, collisions are costly. So how do I monitor that health and make smart decisions for the organization? As you can imagine, that's a pretty thorough system. We like it. It works for moving code up in big droves. But you can imagine that that causes a different challenge, which is time. So in a perfect world, you're working as close to head as possible. This is not working as close to head as possible. And so you've got this challenge where there are times where a collision isn't found until it gets to master, because all those side roads are separated enough that the last place you come together is master, and then we have a problem. And that can be hours, days, weeks after you created the problem. So the next place we want to go that we're partnering with our friends in VSTS on is how do we do pre-check-in validation at scale? Not a new concept in the industry, not a new concept for many of you, but for us, the challenge remains, how do we get that to happen for 7,000 folks working across all of that code and all of those repos? Our concept on this is a familiar one. It's to have the working branch create a set of rolling builds. The rolling builds would have a last known good build that you, as a developer working in your local topic branch, could create your changes and create a pre-check-in build. We're excited in our early pilots in this. We're using Cloud Build for this, and that's a good step forward for us on how to make this work. So if you have your pre-check-in build, first, did it build? Yup, of course, it's a demo slide, so it built. Next, you want to move to test. You can probably predict this is also going to go well because it's a demo slide. And so then you can do your pull request with full confidence. That's the place we're trying to get. And we have a few teams that are piloting this now, working entirely in Cloud Build, doing pre-check and validation so that they're working as close to head as we can possibly get them. So that's kind of an exciting thing for us and where we're going, and hopeful that we'll be able to continue to solve our scale challenges as we get there. So that's all code. We've moved it. Now we should probably, I don't know, test it. So we do automated testing. I always think of validation as having three main things you care about. The first, does it work? Does it boot? Literally, can I get it to turn on? The second is it useful? Does it do the thing I set out to make it do? And the third is, do people like it? Like, it might boot and it might do the useful thing, and people might hate it. So those are the three measures we care about the most. Automated lab testing helps us with the first. The first is all about, does it boot? Does it boot on all these form factors? Does it boot the way we need it to? Can we spot issues early in the cycle? To do that, another slide on bigness. We have a lot of hardware that runs in our lab for 1 day of testing. So for 1 day of testing, we have 250 HoloLenses and 2,500 desktop PCs, 1,200 virtual machines that crank through the automated lab testing. That's big. I showed you that creates, on average, for a release, about 3 billion test cases that are run. But it's insufficient. And so that's where something interesting like the Insiders program starts to come into the picture of how Windows gets its bits from your desktop, from a developer's desktop to your desktop. I was actually curious, is anybody in the room an insider? Insiders! So because folks knew that we were going to talk about the Insiders, I brought, you may have seen these little piles, NinjaCat pins. So please help yourself to some NinjaCat pins. There's some by the door, there's some on the stage, there's some in the back. If you're into the NinjaCat, they're adorbs. If you're not, you can pick one up anyway. So we brought these. The Insider program was excited. We were going to talk about this because it's helpful for us to put the Insiders in context of how we work as Windows. We used to have a long history of beta programs. Work and work and work and work, and then release a beta. Get your feedback, and then go back into the hole. And we wanted to change to a more modern development practice for two main reasons. The first is complexity. So Windows has 8.5 million unique devices out there, 21 million unique apps. So even with one configuration option, you get to an easily exceeds the number of atoms in the observable universe, number of things that you need to test through. Now, that clusters, so it's not actually as large as that makes it sound, but it's a large set of complex configurations and unique clusters that we would lose visibility to if we were just doing automated lab testing. Automated lab testing is never going to catch that level of diversity in the ecosystem. So Insiders is critical for finding clusters that we never knew existed. And the second is latency. It is tough when you have a product that you're building, and then your first beta is when you're kind of close to the point of no return. So we wanted a model that let us get feedback. What do we care about? We care about, does it work? The clusters and complexity help us with that. Is it useful? The Insiders help us through that process. And do people like it? And this is the only way to get that feedback real time as we're developing in the open. So this talks about that transformation for us across that set of releases where we used to have a long period of quiet before we would do betas and then release. Now we're in a place where for our most recent release, for those of you Insiders in the room, you know we have been flighting RS5 out for quite a few weeks now while we were still in the process of RTMing RS4. So it's a really exciting development for us to get to a place where we are developing in real time and out in the open. Insiders, as hopefully those of you in the room know, are worldwide. We cover almost every country. And that collection of Insiders has done 1.5 million quests since October 2016. Quests are the scenarios. They are, is it useful? And do you like it? The scenarios that our teams have spent time curating and developing because they think they solve a problem. And then the quests are the only way we know if it actually did solve a real problem. So thank you to those of you that are insiders. You're a massive part of how we develop and build Windows. And because of you, there are about 500,000 problem reports, feedback pieces, issues reported that make it all the way back to where Ed and I started, to our work management system. All of these things show up on some developer's assigned to me query as a bug or a task or a piece of feedback that then goes through the whole process we just walked through. They start by seeing it in their trackers and in their queries. They move to getting their idea coded in Git, and then they move to testing it, moving it through the branches, and deploying it back out as a flight as close to real time as they can. I thought it might be fun to show a screenshot too of what that looks like on our side when you submit those, which is the release quality view. This is a dashboard that all of the teams, and most especially the directors, look at on a daily basis to check the quality of the release. As we get to RTM, people are looking at it, all the time in real time. As we're in the phase we are now, people are looking at it daily just to get a sense of the health and the health of the build, the health of the scenarios, the health of what we're trying to release. And so it's, to me, kind of exciting to see that full circle happen where we start with someone has an idea in planning, it makes it all the way out to an insider finds something about it that isn't useful or they don't like, and it goes right through the process again. And we have all these customized views built with VSTS data, built on VSTS extensions to help us see how that big picture is coming together. So Ed mentioned that a big part of One ES is about changing the culture. It's a lot about changing the tools, but tool change is kind of hollow without changing the culture alongside of it. And so a big part of what we're trying to do on the cultural side is get to a place where we are sharing all of the work we've done. So we're starting internally. And so just again, a sort of inside baseball story. Inside, we've taken all of our extensions that we've built across a variety of areas and have put them in an open project. So anybody from any of the parts of Microsoft can reach in, grab that code, put it in their account, use it, change it, send those changes back to us. This has been incredibly helpful in uniting workflows across the groups and kind of changing that cultural momentum of like, if you don't have a good way to navigate thousands of areas, we have thousands of area paths, we have built a solution to that. Please use it and make it better. And so we see a lot of that, which is awesome. We're also, as you know from GVFS, trying to get to a place where we share as much of this externally as we can. And so we're starting by putting some of the extensions in the marketplace. That's a journey we're just starting on that we hope to have happen over the next few months. And we're starting to put some of our code out on GitHub. So we have two in particular I thought I'd highlight, the two most recent, where they solve problems that we had at our scale that weren't foundational to the product. They're just not a common use case. But for those of us with the use case, they're incredibly useful. So we've open sourced them so we can share them with everyone. The first was the work item migrator. So you can use the aka.ms link. This will take you to GitHub, to the project where you can go download this code. And the idea here is moving work items from one account to another. Why did we care about that? We cared about that for archive. So you can't be letting 11 million work items sit in your account for too long. That's not a good thing to do. And so we used this to migrate them to an archive account so that we could have a rolling archive motion and keep our production account leaner. I would be remiss to call it lean, but leaner than what it would be if we let it grow unbounded. So this was a huge process for us to get to this place, and so we thought we would share it. And it's been fascinating with this one, seeing how many different folks find this utility useful in a way that we never predicted. So that's been exciting. And then the last one that we just put out is work item one-click. We didn't talk much about it because it's a little bit embarrassing, but we in WDG have mangled the form beyond recognition. So as you're filling in a work item, we have hundreds of fields. And that creates a lot of cognitive load for our developers to have to navigate a form that large with that many fields. So this was a collaboration with VSTS to create something that you could create that allowed you to set personalized defaults I'm not always going to know what the right default is for 11,000 people, but you will always know what the right default is for you. So you can set your defaults, and then you click this cute little button, and it puts in all your defaults for whatever part of the workflow you're in. So this is another project we've shared out. Not sure who will find it useful, but you never know, and so wanted to get into the habit of sharing is caring. So with that, Ed and I want to thank you so much for attending our session. We'll be around afterwards for questions. Please grab pins and stickers. And I hear you can win a drone if you do this. So be sure to fill in your evaluations. Thanks, everybody.